Hello, everybody. My name is Andrej Kiš. I am from Think, and today I'm going to talk to you about Glamorous Toolkit. So we're going to show you a bit what's new and show you a bit around Glamorous Toolkit. So at Think, what we are interested in is making the insides of software systems explainable. That's our goal, and Glamorous Toolkit is a way to achieve this goal. And just to give you an idea of this, what this means in like 30 seconds, here we have several object inspectors. So we're looking at a lot of domain objects here. We can see the object inspector, we can see how these objects are implemented, but yeah, they look quite similar. From far away, you will not be able to tell the difference. So generic views can help us in some ways, but yeah, they're not necessarily the best way to approach things. But yet, if we change the view, then we can reason very differently about our systems. So these are the same object as before, but this time we can reason about the internals of these objects. We're not just looking at the implementation. So in short, this is what we're trying to do in Glamorous Toolkits. Make things as much as possible explainable. So now let's start with the demo. So what we've been working in the last year in Glamorous Toolkit was mostly connecting with other runtimes. So I'm going to show you what I mean by that. So first we're going to start with a demo in Pharo, so using the Pharo as a runtime. So here we're going to use a movie demo for the beginning. So we're going to have a file that contains some movies from IMDb, and then we're just going to import this and create an object model. And of course, maybe first I should execute the first snippet, and then I'm executing the second snippet, so now I have an object that represents a movie collection. And now we have some views. For example, we can see movies by director. Maybe I like one director. Then we can see the movies by the director, and if we select one, we can get and see the actual details of the movie. So we just have a domain model, and we have different views to navigate through this domain model. Here, all in Pharo. And if you're interested about the implementation of one of these views, we can alt-click, and now we get its source code. So we can see it's a column list that has a title, a priority, so the order, displays items, and then has two columns, more or less. Now, let's try to do this in another environment, not just within Pharo, using Pharo code. It will be using Pharo code, but this time, let's try to look at the Gemstone. So Gemstone is an object-oriented database that can run also Pharo code. So this means I'm going to execute the first snippet to get the file. The second snippet is going to import the data within Gemstone. And now this snippet here is a Gemstone snippet. So it's going to execute this code in Gemstone, that's running on my local machine in this case, and give us back the object. So now we are looking at a Gemstone movie collection object. So what the views that we see are the views for the data that actually lives within Gemstone. And we can do the same. If I'm interested in this director, I can go at the movies, I can look at a particular movie, and I can look at details. So now we're browsing the same domain model as before, but in a totally different runtime. So it's Gemstone now. And interestingly, as before, if we want to know, for example, for the years, what's the implementation, we can alt-click, and now we get a proxy to a Gemstone method. So now we can see the source code, which in this case is identical with the Pharo one. So the source code is the same. We just build a view either in Gemstone, or we build a view either in GT, more or less. But now let's try to move to another environment, this time Python. So we've implemented the same domain model, so a movie collection followed by a movie in Python. So let's run this. First, to initialize our file, we need the file name. So now we're going to use pandas to parse this CSV file and get back a data frame that contains all the data in our movie collection, and then initialize the movie collection with that data frame. So now it's no longer any Pharo code running here, it's just Gemstone. So now we get back a movie collection object that lives in Python. So now we're looking at a Python object that lives in the Python runtime. And we still have the same views as before. We can still navigate, so I'm going to select the same director. We can look at its movies, and we can look and see what details the movie has. So the same workflow that we did before, we can do in Python. And if we look at the implementation of a view, again, all we have to do is alt-click, and we get the source code. So this is defined in this Python file, and this is the source code of the view. So the Python object can define its own views using exactly the same API as in Faro or in Gemstone. And then we can show it the same way. So we can use GT to also browse domain models in Python the same way as we do in GT. For the next one, we don't have yet a movie collection demo, but this is Rust. So part of the graphical framework in GT is written in Rust. So we have Rust data structures. And often we need to look at those data structures and understand them. This is actually a page that you'll find in our documentation. At a certain point, we had a bug in the editor. Something was not right in the data structure that we're doing in Python. And not in Python, in Rust. And it was hard a bit to understand. So what we did is build some views for those Python data structures. And I just want to show you that now. So this has to do with the editor. So I'm just going to first inspect some Faro, some GT code to get the editor right. So this is an editor, and behind this editor there is a Rust data structure that contains the text and the information about styling and something else. So now the second snippet gives me part of that data structure. So now we have in our case a Skia paragraph, and if I look at the raw view, it's just as an external address. So this is an FFI external resource that points to some part in the memory, more or less. And we can add some information to this object. So it has a view that says, for example, line ranges. This is what we're interested in, for example. But now I can select this object, and if I dive into it, this is actually a Rust vector. So this object only exists in the Rust runtime. But we can still add views to it and interact the same way as we do with a GT object, a Gemstone object, or a Python object. And we can also continue. Maybe we want to inspect this, and now we're looking at the range object. And this proved to us quite useful in finding these bugs that we had in the lower level part. We could always go and look not just at the ID level in our case, but also go back to the data structures from the actual Rust. And now if I alt-click here, for example, we get the source code of this view, which is Rust. So we can attach views to Rust data structure in Rust. And the API is exactly the same, but okay, with Rust syntax. We want a view, we must have this annotation, we set the title, priority, and how we get the items. So more or less, if we go back, it's the same metaphor. We can have objects or data structure, attach views to them in the language of that runtime, and then use that in order to reason about and inspect those. It's not just limited, for example, to working in GT, with objects in GT. It can be easily extended even to Rust, for example. And to give you a more real-world example, so this is more of a toy example, but now let's look at a concrete example. So there is this library called Tokenization. It's done by Andrei Karpathy, one of the main guys behind OpenAI. And there they have a tutorial where they are trying to explain tokenization to people. So they have their Python code, they run the Python code there, and then they have another web application. There is the link to this tutorial. You can use this also page in GT. You have to go to another web application to reason about tokenization. So they have various different applications where you can understand the reason about. But we thought, yeah, could we just do one? So in our case, we're going to get a lore ipsum, just so I have some text. We're going to just get our Python. Now we're going to just import the tokenization library. And now we're going to explore and inspect how this tokenization result is. Okay, this is not that useful, but now, for example, what we can see here is the final result of this tokenization, that of this text that you get from this Python library. This is a Python object that lives within Python, and this is a view of that Python object that we can show. And interesting here are these type of tokens, because these type of tokens, usually they are small and then they get concatenated. And then if we want to see how that happened, we can click. We get back, in their case, they have a merge object. That I can see that this token here was obtained by merging this token and this token. So all of a sudden, we can go through the merging algorithm of how the tokenization happened at the level of Python. And we can reason at that and explain that. So it's much easier than to do it directly in the IDE, than to have to go to another application, doing that, coming back, merging. We can do the same, and all we did was added several objects, several views to these kind of Python objects. So now about other environments, let's look more about what we can do in GT. So in GT we have Lepiter. So this is our knowledge management platform, where we have different types of snippets, we call them. You saw a Python snippet, a gemstone snippet that we can use to connect to runtimes. Okay, Pharo snippet to execute Pharo code. And then we can also have other snippets. One that we found useful that we added recently was a shell snippet. We all, a lot of times, need to do work with the shell, like install scripts and different things. And we wanted to be able to do it directly from GT. So for example, I could just go and say I want a new type of snippet, and in the list somewhere should be shell script. So now we have a snippet that can execute shells, commands in the shell. So let's start with the simplest one, maybe just ls. So now I get the output of my ls command up till here. So we can have a command, execute it as a snippet, get back the result, or just execute it in the background if that's what we want. But now, yeah, this is just a command here. It's maybe interesting, but now, yeah, we wanted to make it even more interesting. So let's say I want to pass parameters to this one. So above I have a Pharo snippet. Let me say I have some computation. Maybe I compute the name of a directory. So let's say I'm interested in GT4 gemstone, for example. Now I created this variable, and now I can reference it within the actual shell snippet. So I can say I want a name. So now when I'm going to execute, it's going to give me the code, the content. That's sad. I'm going to need this later, and maybe also battery, but let's see. Maybe I should log in. Let's put it, does it disappear? We'll come back to this later. Okay, so now I did this, but then, okay, maybe I want to process this result next, because now I have just the result here. So I can specify a binding, so maybe result. So now if I execute this, there is a variable that's bound, play a result. In this case, I can copy its result. So now I get back the result. So now I can have my computation be Pharo computation, Python computation, shell scripts, getting back the results, passing them to some others. We don't have to just have independent things. And to show you just, and just to show you a more simple example, but still more, yeah. Now this was a toy example. So here I'm going to use, for example, first I just say I want to plot on a just to plot on a scatter plot the classes with the highest number of methods in the system. So I have my Pharo image, and I want to get the classes that have the 20th highest number of methods. So this is my script. So I'm going to say I'm going to have all classes sorted by size, and then get the first 20. I'm going to format them, in this case, as a CSV. So if I execute this, I'm going to get back more or less this CSV that gives me this data. Now we can do some meta programming. So this snippet is this current snippet. So I can say from this snippet, I want to give me my previous snippet and give the content of that snippet. So if I execute this, I get a variable that holds this content here. And now we can pass this code to an image. So here I'm going to run another GT image where I'm going to pass this code, and I'm going to get the result back in this binding. So now this is running, this is all async, and now I get the result. We're going to do some processing, more or less I'm going to trim. I'm going to get the data as an array again with Neo.json. And now we can plot it, for example, using some scatter plot, for example. So this is something that we can then all do. Can easily create analysis that combine, for example, Pharo code and visualization and also shell scripts. They don't have to be different. They all can be within the same workflow. And very quickly, this snippet existed before a bit, but we also improved it. And when I mean rewrites. So often we have tools for doing refactorings. We want to change the code of a system. And then how do we make those tools also easily embeddable in this kind of workflows? I have here a method that has this pattern. Children if is nil, if true, return self. And I would like to replace this by if nil. It's a bit redundant to say is nil if true. I could simply use if nil. So let's do that. I will start by saying, I need another tool. So this tool is going to be a Pharo rewrite. And now this asks me for two things. First, it will say, where should I search for? What should I search for? I'll say, okay, search for this, please. So now if I'm going to execute, I will just get one match. Right? It's specific like this. And now let's say I want to rewrite this to just be if nil. I can execute this, and now I will get back a rewrite object that shows me what is it going to do. So it's going to rewrite this to this. So now if I execute this, it's going to perform this rewrite. However, in this case, I match this exact source code. I would like to match maybe more generally, find all these instances where I have this kind of pattern. In case you don't know the syntax of the refactoring browser, or RB, we can always do it in here with the menu. So I can say I want to match anything here. So now it knows to replace children and children here by any, because it knows that they are the same. And maybe I can do self, again, I want anything here to be. So now I have any here, and maybe I don't like that it's named any. I want it to be, I don't know, content. So I can refactor. And again, the editor knows it can refactor both snippets. And now I can execute this. I get back a lot more results. And if I execute this, again, I will get the refactorings, 220, 212. So now there are different patterns. But also, if you look here, there are many classes, for example, and packages. Let's say I want to scope this refactoring only to, for example, only to Glamorous Toolkit packages, or packages that contain Glamorous Toolkit, or some way scope it. How do I do that? Well, I can do before another Pharo snippet and define my computation. Let's say I want to create a filter. I just create a binding. I can call it anything. I will call it maybe filter. And now I'm just going to create a normal filter in Glamorous Toolkit to search for methods that are in a certain package, in a package with a certain name. So maybe, I don't know, Glamourous, and now GT, if I can. GT package matches, or it was this one. Yes, so now this is a filter that gives me methods that have this Glamourous in their name. And now here I have a place for specifying what to search, and by default I will get some filters plus all the bindings that point to a filter that I've already created. So in this case I've created this binding, I'm using it here, and now if I run, I did something bad. Yeah, it should be here. I don't know what I did wrong, but demo effect. But that's the mechanism in order to scope this kind of things. There is a next demo that will show it. We can only not just apply this to Pharo code. So here we had a snippet for Pharo code, but we're also using SMAC, which is a parser framework. And for SMAC, we have also other types of parsers. For example, a Rust parser. So we can do the same for Rust. I will just initialize here a few things. And now here, for example, we have some kind of pattern in Rust that we will not like to use. So for example, we have assert equal, something is not null. We can just use assert not null, for example. So we'd like to perform this refactoring. What we can do is use another rewrite snippet, specify that we want a Rust parser in this case. And then again, we can search for all things that are matching this, or we can perform the refactoring, and then we get back an object saying us how the refactoring is going to be performed. So now we can use the same to refactor, for example, Rust code, if that's what we want, or any other parser that's available in SMAC. And now I would need internet for the next part of the demo. Let's hope that. Sorry, is it working? Oh. If this works, this would be wonderful. But not for internet, for battery. Or
yes, internet.
Internet?
Should be okay.
No internet. Yeah, no. It works. That's unbelievable. There is a cable for internet. Okay, so now for the next part, let's look at another more open development, so that is OpenAI. So we'd also like to be able to create these tools or to interact with LLM from GT. So first I will show you a bit of a programmatic part, then a bit of a use case, and then Thursday, one of my colleagues is going to show you a much more elaborate demo about how we are doing this. So first, what I'm going to do is create a tutor. So this is an object that handles the communication, and this object, for example, has instructions that it passes to the LLM. So in this case, we're telling the LLM what we want to do, what we expect to communicate, how conventionally should follow, so all these instructions that we expect the LLM to follow. And then we can ask for a chat. So this is going to connect to the LLM. and is going to open a chat that we can use like in the web browser, for example. So now I can send it a message, maybe write a snippet that divides 5 by 3, and then at a certain point, if all goes well, we're going to get an answer. And now we can directly execute here, for example. If we have Smalltalk code, we can execute it, and in this case, we get the result, which is 5 by 3. So we can do this interaction directly in the IDE. In this case, we can also, if you get an object, we can also create another message from here. So we could tell the LLM, please create me a message because I want to know more about this object. And we're going to send it. And eventually, yeah, we can collapse this. We're still waiting for the output because it's typing. So it says, I don't know, the snippet successfully divided 5 by 3, return a function, something, something. And we can also write messages here. We don't have to just programmatically send messages. So for example, we can say, I know, write me the code to get the list of all classes from the image. And hopefully it will return us something. And if it's valid Smalltalk code, we should be able to directly execute it from here. Yes, Smalltalk globals, all classes. It worked. So now we got this and we're able to interact. So this is the high-level infrastructure that we use to communicate. And now let's look at one example about how we can integrate this within the IDE. So for this, I'm going to use wordly map. So we have a snippet where we can create a wordly map. And the wordly map, for those of you who don't know, it's kind of a visualization to help businesses make decisions about their domain. So you have to place more or less abstractions from your domain on a value chart, more or less. And then maybe you don't know where to start, let's say. I want to create now a map about moldable development, but I'm not sure where to start. Well, I could just ask the ChatGPT, OpenAI, to give me an initial one. So I say moldable development. So now, hopefully, it's thinking. Yes. And while it's thinking, I can also inspect and see what's behind. So we can also go back and see the list of messages that it sent. We don't have to just... and now we got initial. I can accept all no, so now we got an initial map from the LLM. In this case, about a wordly map. We can also do many actions programmatically. For example, maybe I want another node that's connected to this one. So I'll say, please give me a new connected node. Now it's going to create another message, and it's going to wait for the LLM to come back a result. And if you look at these messages, you see we can show the content. So this is a textual representation. But you can also show a view that shows that message in a different way. Because the message is an object, so you can have different views to look at the same messages that you're sending to LLMs. So in this case, it suggested me IDE plugin, and I can accept it. So now I can continue. You can also ask here for many other types of messages that you can interact with the LLM. So you have a way to have kind of moldable messages that can be represented in different ways, not just textual all the time. Very quickly, so this is our Git tool. This is exactly as it was before, but one interesting thing is now we moved to use the Git, the command line Git. So we're no longer using libgit, except to bootstrap. Otherwise, we're using the Git install on your system, more or less. This solved some problems for us. Yeah, this. So for example, here, if I do some operations, this is a log of the commands that were executed. More or less, now we're using Git commands, for example, git show, git tag, git branch. So we're delegating this to the Git executable. And last but not least, something that we added recently was a way to better integrate browsers in GT. So here I have a URL, for example, to the ESUG, and I can open it in a web browser. So now I have it. But then often, we might want to not have to open a browser to do this. Why? So what we can do is, for example, in this case, I will inspect the URL, and now I get a view that shows me this web page. So this is a web view that directly embeds the browser within GT. So now, for example, I can browse the page when it has a link to GitHub. I can browse GitHub, any other, like a normal browser. It just takes your local browser, and it can render it within GT. When having this, we can do a few interesting things. For example, we have a YouTube snippet. So this is a YouTube link, and instead of clicking and opening, we can paste it, and now we detect it's YouTube, and now we get a YouTube.
Hello, my name is Oscar Nielsen.
And we can play YouTube videos directly in GT, if that's what we want to do. We don't have to go somewhere else. And of course, if we have browser, we also have D3. I don't know how. So this is for, I just opened this page from observable, and there is a visualization. So, but yeah, this is like the same with ESUG page, but then if we can render D3, we can also build views using it. So in this case, we just have a small example where, again, the same list of 20 classes. So I have a list with the top 20 classes by number of methods in GT. And I want to render them using an interactive bar chart. I could create one in Rosal, but then I can also use this one that exists in D3. And I can also, we have callbacks back to GT. So if I select one bar, I get back the class object in the same navigation. And if we look at the source of this view, it's just some HTML that does the D3, some JavaScript that creates the D3 animation. And once we added this, some clients that were using this added, for example, this view. We are surprised, but it's quite nice. So for example, they are using the profiler to profile various things. So in this case, they're using message tally. So normally in message tally, you have the text report. In GT, we also have a slightly different way to look at it as a tree. But they really wanted to add a flames chart, so this kind of chart. So this is just a D3 chart that they added, more or less, to use. And if you, for example, this is just a web page. So if I go to the browser, here I have exactly the same web page, which is just D3. But we can take this and create views based on them. If something's there, first it will be nicer to have them implemented in GT, but if we don't, we can still use them and play with them. Okay, so if we take a step back, we can see that again we have different kind of small tools that we can take and combine. A tool is not something that is monolithic. Tools in usual case are snippets that we can take and combine in workflows, any workflow that we want. The same workflow can contain a refactoring, a visualization, YouTube, or Bash, or any other tool that's available in GT. And like you saw yesterday, this does not only apply to inspectors, for example. You can do the same for the debugger. So here we have 4 live debuggers, actually. You can interact with them. And these are 4 debuggers that are for 4 different domains, more or less. But again, like the inspectors we saw at the beginning, they all look the same. From far away, they will be identical, which means, again, we are the ones that have to manually extract information from here. But then we can use, I have to select this. You can also move to domain-specific debuggers. It's also possible as we extend the debugger to extend, as we extend the inspector to also extend the debugger. And just to end, this is just a small example of a GT, so it's an inspector that has more or less 2 panes and some views. And in GT, we do not consider tools fixed. So for us, we view the user interface as a language. We view the user interface as a language where we start from a frame. We have a flow. It can be a linear flow, a tree flow, some kind of flow. And in this flow, you have snippets and views that give you the details, and then within those you can embed content. So the user interface is not something that you view as fixed. We view as something that can be customizable and that users can use to create their own custom workflows that are not necessarily fixed. We just provide the components, and users are the ones that are free to define and combine them in whatever way they want to. So that's what I wanted you to show you. If you have more questions or if you want to try it, just go to utool.com and try it. Yes.
Thank you on the great presentation. It's impressive. My question is about, I've seen in the scripts you can choose different languages. So how easy is it to add a language? What is the requirement to do it?
Okay, depends how you want to implement it. So we can also connect, for example, to the language server protocol. So for example, for Rust, we have a parser, but we did not want to implement, for example, all type inference. So for that, for example, you can already connect to the language server protocol. So if your system has the language server protocol, it's just about instantiating it and connecting to it. For others, if you want more custom things, you'll have to implement them yourself. For views, for example, we have kind of a standard JSON that we expect from the remote side. It's kind of standard format. So we have implementations for that in Python, Rust, and all this that you saw. If you want another one, you'll have to implement that API there and then return the data that we expect, more or less, and then it will work. But it will not be like a few hours. It will be a more complicated process. But you have like 5, 6 examples of this type of connection, so you will not start from scratch. Yeah. Perfect. Then, thank you very much.